Sorry, I had my mic muted. We will get... I was going to say, I noticed we've got a couple people jumping into the stream, though I never know how much to trust this viewer count, because I know that like I should be counting for at least 2, but my count is not equal to that. So it gets a little weird. Cool. Sweet. Okay, well, I guess this is roughly starting time, so I will kick the stream off and get things going. Hey, Xavier. So tonight, for anybody who's watched my stream previously, rather than doing the material design in XAML, we have Jon with us, and we're going to be going over and doing some looking at the System command line library. So, Jon, I am sure you can do it much better justice than I will. So if you would like to give an introduction, and then you can dictate where we're headed from there. Hey, Jon, hold on one second. Apparently, this guy is not... Jon, go ahead real quick, would you? In my haste to set this up, I did not apparently grab your audio source, so one second. Let me see if I can pick you up real quick. Monitor... Because you come through for me, but it is not going back out, which is not helpful. Okay. Thank you, Xavier. I appreciate that. Speaker. So let me see if I can pick you up from... Jon, I may or may not have to call you back, because I think I may end up having to grab... It is not giving me the outputs that I am looking for. Let me see if I can just redirect you to one that is showing up. Come on. So now I've got you going out, Jon, but now I can't hear you.
I didn't say anything. How about now? Any better? Mic check. Mic check. No luck?
Okay, there we go.
Aha!
Okay.
Very cool.
Sweet. We will go this route, and Xavier, if you want to let me know if you get too much feedback from him. For some reason, I cannot pick up my audio, the same audio source from this. So, but this one will work. So, Jon, if I can reset you a little bit and have you jump back to the beginning, that would be great.
Yeah, sure. Whoa. So, yeah, this is the System CommandLine project. This has been going on, it has its roots in the .NET CLI, where when I was on the .NET CLI team, we rewrote the internal parser for that for a number of reasons. And then it kind of evolved over time when the .NET global tools initiative got kicked off, Kathleen Dollard was looking for a decent way to give people in the community a foundation on which to build command line apps. There's a lot of parsers out there in the ecosystem, but we sort of identified a few different reasons why we might want to take another stab at this problem. It's been solved a bunch of times, and a lot of it went to going a little bit beyond the parser itself and into building, what else do you need for an application? You want testability, and you want invocation of some kind of a method. And you want, eventually what we realized is people would also find it very useful to have rendering to the console and to be able to do things like animation of output. And then we started looking at VT100 rendering. And so it kind of spread out from there. And so right now, it's on NuGet as System.CommandLine.experimental. And that's because the API is still somewhat in flux, and we're trying to figure out what is the, what is it that people might want? What should be in the box and what should not be in the box? So you'll see it's still got an alpha tag on it. And one of the things that I'm working on right now is a change to some of the core parser to enable better performance and a little bit of a clearer API. It's one of the goals. There's a few different issues that I'd like to be able to resolve on GitHub. And when I started looking at it more deeply, I realized that there was, the core parser itself could be made a little bit better. It was always a little bit of a, get it working and then figure out later how to make it really good. So we spread out, added a lot of features in other areas, and now we're kind of circling back and trying to polish things up a bit. So with that in mind, I had reached out and said, hey, do you want to take a look at this parser redesign, Kevin? Because Kevin's been involved in this project from very early on. And so getting some opinions on the direction of the API changes and the thinking about the new parser, something that I wanted more eyes on. Is it worth it to go through some of what?
Yeah, I was going to say, do you want to just give, I guess, a kind of to get everybody on the same page as far as when it comes to terminology? Because it's easy to say parser, but I think kind of breaking down the various constructs from the commands, options, and arguments, and then kind of the current structure and the problems we were running into.
Yeah, absolutely. So when we think about a command line parser, right, the one way of, the most basic thing that the command line parser is doing is it's taking command line input. So if I say, I'll say .NET try help, right? So here's .NET try, which is something we've been working on, and it uses this new system command line. And it understands some things about what are the different options and commands that are available in the application. And it has this responsibility to then be able to take in this input, and whatever that command line input might be, right? I might go .NET try some nonsense, right? And it needs to be able to say, oh yeah, that doesn't exist, right? There's valid. It understands what the meaning of that third token is in the context of this app, and says, oh, it doesn't work for this particular thing. So effectively, the parsing part is interpreting the raw text of the command line into some kind of, something that's meaningful to your program. .NET has always had an entry point for programs that looks, something like this. Oh. Right, the very familiar, nope. Visual Studio Code is something like this. Right, so you have a main method. It takes in an array of strings. And this will get parsed for you by, upstream from your managed code, effectively. This is going to get parsed into these arguments for you when your entry point to your application is called. So the most rudimentary command line parser is, you might have expectations that certain tokens appear at certain positions inside of this input, and you just sort of take for granted that people pass the right input, and you parse it, and everything goes wrong if it's wrong. something's in the wrong position, you'd handle all of this manually. So the simplest command line parsers allow you to just pass those args into something that gives you back something more meaningful. Maybe something with specific types. Maybe some of your arguments are intended to be integers. Maybe some of them are intended to be optional. Some of them are intended to be required. Maybe you have subcommands. And as you look at more complicated command line applications, you'll find that the kinds of input that you might expect can get very complicated. You might have a whole list of different subcommands with a whole bunch of different options under each one of them and all kinds of different rules about what kind of input can be passed. So we wanted something that would scale from the kind of simple use case and let people get up and running really quickly with it, up to the more complicated kinds of use cases like the .NET CLI, or might think of a complicated command line application like Git. And to be able to tackle a bunch of these different kinds of use cases. And then kind of the next step from there is we said, there's a lot of parsers out there. Why is it necessary to write a new one? The .NET CLI was a really, really complex beast. So it had a lot of requirements existing. And then we wanted to be able to add some additional features and make things easier for people as well. One of the ones that we show off a lot is tab completion. Right. So because our parser configuration understands the semantics of your command line, it's able to, and the structure of the commands and options and the hierarchy that they exist in, it's able to provide completions for you. That's something that is normally really, really shell specific. People will write a shell script that works for Bash, but not for PowerShell, or for PowerShell, but not for Z shell, and things like this. So we said if your core parser understands the semantics, why not make this something that works across all shells? And that was a really compelling idea for .NET Core, which is cross-platform. So that was one of the things that we started thinking about. And then we, other things kind of got added in as we went. So maybe you want to find out how the application is going to interpret your input. So we have this notion here of being able to pass in something that we call a directive. And this is something as well. There's a lot of different ones in here that allow you to have expectations about how you can interact with your command line application that will cut across applications. So, parse lets me understand how the parser is going to interpret my input. There's a debug directive that allows me to break in mid-parse and attach a debugger before the entry point is called, which is a pretty common scenario for developers who are working with this sort of thing. Suggestions is driven by this as well. So these were some of the features that we said this would be really useful for a lot of people. So that's kind of, and then model binding came into this as well. So, we said, well, wouldn't it be great if I didn't have to think about the parser at all? Really, no one wants a parser. They just really want their application to be invoked. So that's where the Dragonfruit concept came from. The Dragonfruit concept gives you a main entry point that has strongly typed arguments instead of the string arguments, because ultimately this is what you want anyway, right? You want ints and enums and strong typed things. And there are abstractions here as well that are passed in a sort of a dependency injection manner, which are System.CommandLine concepts, like this invocation context is here. You can get a parse result object, which gives you this kind of rough abstract syntax tree for the parser input. And you can get a console instance passed into you rather than being constrained to use the system.console singleton, which is a big problem for testing and so on. So that's kind of a rough overview without getting into the rendering stuff, which is a whole other.
And I think that's a pretty good one there, John. And for anybody looking at this, like the Dragonfruit, I've written several kind of small CLIs using it, and it is by far the fastest, easiest way to spin up a new console application. Being able to just public static void main, file info as my parameter. I now have a CLI that has help support, auto completion, everything for passing in a file, which makes it really, really easy to work with.
Yeah, we can demo this in like 2 seconds.
Yeah. Do me a favor, John. Can you bring your console window up a little bit? Yeah, just because the Skype controls at the bottom occasionally are.
Oh, I see.
Every time I move my mouse onto that window are floating over where you're typing. So there's also, for anybody who wants to play around with the Dragonfruit stuff, on the GitHub repo under the wiki, there's actually a really nice getting started page. in there for the Dragonfruit stuff that you can walk through, and it'll take you from essentially exactly what John's showing right here, from .NET New, give me a new project, all the way to, okay, let's actually build and run this.
So I created just an ordinary console app, which you can see here. Right. But I added Dragonfruit to it, and so what that lets me do now is I can say, well, maybe I want a strongly typed argument, int blah, and maybe I give it a default value. Right. So now, when I run this by itself, I see 5. I don't know what that 5 means, so I can say .NET Run. Now, I can, .NET Run here is just, I'm passing arguments into my application rather than publishing the application and creating its own exe, if you're not familiar with what .NET Run does. So this is able to tell me some things about my application already. You'll see that I've got a version given to me for free. Help just worked for free. When help was invoked, my entry point wasn't called, things like this. And then I can go, I can also add more details for help. Am I doing this one right? Blah.
I think you need your triple, yeah, there we go. And probably need to set the debugging flag on the CS proj, if I remember correctly.
Debugging flag.
Yeah, because I think by default it doesn't output the XML with those comments, which is what Dragonfruit's reading.
Yeah, but I thought the Dragonfruit target set this up for free.
Oh, that could be.
I think they do. I think I just might have gotten the XML comment wrong. Let's go back to my existing example. I'm not sure. Oh, it's got to be inside of a summary.
Summary's terminated on line 19.
Oh, you're right. But we'll grab that too. So apparently the way that we process the XML, that's a bug, I guess. The way that we process the XML comments, it looks like if the summary is missing, we don't move on to the params.
Ah.
So that seems to have solved that. So yeah, this was an idea that was based on, and you can see things like this, the directive, right? So if I say parse 123, right? Here's the blah 123. And if I run it, it works. So this is the idea here was to sort of say, people don't want a parser, they really just want an invocation. So a lot of System.CommandLine is doing, and Dragonfruit is just a layer on top of that, is providing you with a default parser based on reflection of your entry point and analysis of your XML doc comments.
Sweet.
So that's kind of where things are today. And this is, if you want, we can get into some of the details of the parser itself.
Yeah, I think at least for now, that's probably a good overview. For anybody who wants to dive deeper, there's been lots of pull requests, lots of people giving feedback on the GitHub. So I would say my advice is pull it down, especially if you've got a new command line app that you're looking to build or just want to play around with it, and give feedback. I mean, that's been one of the big things, is we can build just about anything, but knowing what to build and what's correct is always difficult without knowing what the pain points are and that sort of thing. So I tell people, pull it down and grab it and let us know where the problems are and what's exciting and what's not. So I guess, John, then let's take a look at either some of the issues, or if you want to talk through kind of the problems that we've been running into with the parser that's driving the refactor. And then maybe start diving into some of those details. Because if nothing else, that's interesting to me, and I'd like to understand it.
Yeah, well, and you can just ask the questions that come to mind, and they're probably the right questions.
Yeah. So I guess my first thought is, so what are the actual issues that we were looking to solve? Because I know there was the issue of single versus multiple arguments on on an option. So
that's really the thing. So that's the one that triggered. Sometimes you push an abstraction to its limits, and suddenly something triggers a change that drives a whole bunch of other things. So this is the issue here. Number 310. It's been open for a while now. What this issue is saying is that people would like the ability to have multiple arguments for a command. Now, let me explain what that means. Right now, if we look at, we can show this with Dragonfruit.
Mm-hmm. And I think
we'll go back.
Dragonfruit's the easiest way to see it.
Yeah, yep. This doesn't get into, so what's happening is when the Dragonfruit application starts up, there is, the real entry point is being emitted using an MS build target. It finds the entry point that looks like main but is strongly typed, which is the Dragonfruit special entry point, which is your code. It does some reflection. It finds some things out about the parameters and their types and whether they're optional and whether they have default values. And then it configures the System.CommandLine Parser based on those things. Now, what you can see here and it recognizes a bunch of different possible tokens for help because you don't know how to ask for help until you ask for it. So we recognize a lot of different things for help. /? Being a common one in Windows world, whereas -H is more common in POSIX, non-Windows kinds of command lines. So this here, it's showing that we have some options here, right? So here's the blah option that I created. We need to push a new version of this up because we've gotten a little bit better about this, what to call the argument, like if it's a bool. This is a fixed issue, but a bunch of people, that's not going to work, is it? So we also added argument support here. So what an argument is I can say, let's just call it string args. Save that, and we'll look at help again. So here you can see this little arguments section came in. And so, here's the usage that call the app. We can pass in some options, and we pass in args. So an arg would be defined like this. If I do, let's go over here and say, each the random typing thing is an oversensitive trackpad. Always fun. Okay. All right. So the arguments that you'll notice, and again, ignoring .NET Run and --, everything after that is really the input we're passing to the app. What you see there is that we didn't need to specify --args or the equivalent of a --, blah. Arguments are they're effectively positional.
Yeah, or unnamed, I think, is something that people have thrown around, though not completely accurate. But because unnamed usually precedes something like option, which isn't quite the same thing.
Yeah. So to get into kind of the syntax concepts, right? If we say blah 1, 2, 5, whatever. I'm also going to have to go in here and we'll do console right line blah.
Your blah is still a bool, by the way.
We'll put it back. So just to make this clearer, right, you can see that by specifying the option, we're saying, hey, this next token is this named option. Those other things, they're args. And it's not strictly positional, as you pointed out, because I could do it this way as well. I could say 1, 2, 3, like this. Within the context of one command, we actually allow options and arguments to be specified in any order. So really what the option is doing, the dash dash blah is the name of the option. The option itself has an argument. So the way that we structured this in terms of the syntax concepts in the parser is that in this example here, blah was an option, 3 was the argument to that option, and 1 and 2 are arguments to the root command, which is your executable. So does that make sense? Does anyone?
That makes sense to me. There haven't been a lot of questions. There's been a lot of surprised and happy faces and excitement over Dragonfruit, I guess, which I think is usually normal. Anyone who's had to go through and try to like parse that string array themselves knows the pain and difficulty that comes along with it.
Oh yeah, it's one of those problems that everyone has solved a few times, and that was kind of one of the motivations. And there are other parsing libraries out there that have done a great job at this too. So the thing that's being asked for with the issue number 310 is the ability to do something more like this. Right? Imagine that I wanted to do my app, blah, 1, 2, 3. And then maybe I wanted 2 different arguments in there. A great example of this actually is Git's got a few of these, and I think this is called out specifically in the issue, right? Git remote add options, name and URL, right? So what you've already seen here is that the parser already understands how to bind things to specific types. Right, but arguments for us, and the arguments, to be clear, can be a type other than string, but they all have to be the same type. Right, so I can do this. Right, and so if I come back here and I say .NET run, and I just pass in some args like that, right, I'll get a parsing error from this. I would like a nicer error message for that, but you get the idea, right? It didn't recognize 3 as a valid argument because it wasn't an int. We can make a nicer error message for that one. So what this issue is really asking for is the ability to have separate arguments that have different types. In the example here, right, git remote add, various options. Name would be one argument, URL would be another argument. And the expectation here would be that using System.CommandLine, you could make name a string, and URL could be constrained, for example, to be a system.uri, and that should just work. The problem is right now is that we don't have the concept of multiple arguments for a single command, multiple different types of arguments for the same command.
So, Tide, I'm not sure I understand the question you have here. So he says, off the top of my head, can you provide a type template? I'm not sure. Do you mean a type converter to basically convert from one of the arguments into a different type? Is that what you're requesting?
I think there are. Yeah, and by the way, I'm also able to see the comments over here. I'm actually on the stream on a separate machine. So.
Oh, good, perfect. That makes it easier. I was trying to keep track of that for you, but I'll let you then read as well.
Yeah, I don't quite get the question. I think there's, let's see, class or something that we define the type for each arg. Let me show what the API looks like. I think there's a lot of great ways to solve the problem. And how it gets solved at the API level is sort of a different question than how it gets solved at the parser level. And so right now, the parser itself is not able to understand this thing. So let me show what the parser looks like. That piece of it. The object model for configuring the parser has a limitation here, which I have this kind of long-running branch that I've been working on to try to solve this problem. Actually, we merged the first step before it. So let's take a look at some of the parser tests. All right, so here's an example of the API. We've created a command. We can add an option to the command. This also supports collection initializers, which I think are a little bit easier to read. So we can also do this, just to be clear. I think this is a much cleaner API. Ooh, I'm typing faster than. Ooh. Let me back this up. The collection initializer API, I think, makes the object model a little bit clearer. So let me just quickly do this. Use a collection initializer. So I can add an option like this. The option is the child of the command. I can do the same thing for arguments. So let me grab this argument. I don't need to pass it to the constructor. I can pass it to an object initializer. All right, so I think with this API, I see, okay. I'm getting ahead of myself. This is the API that I want to land on for arguments. And the idea would be that more than one argument would be able to be passed in, at least to a command. I think, actually, that's the problem. Yeah, this works for command. Okay, so this is a command argument. All right, options are not allowed to have multiple arguments, but commands are. So that's a recent change to the API. So if this piece of it makes sense, and the argument can have a type. Right. So this API here would then allow you to, pile up your options and arguments next to each other. The command could specify multiple arguments, and this feels like a fairly natural way to build up the hierarchy of commands and options and arguments. I think it's better than it was. The problem right now is that this doesn't really work. But notionally, this is kind of what we're talking about, right? So for the Git example we were just looking at, right, you might have an argument called name, which is a string, right? So this would be git add remote, might look like this. And you'd have another argument, which would be a URI. So forget about parity. And that would be kind of what the remote command would look like. Right? It would be nested under another command. Like this code, I'm sorry, this one would be like this. New command add. And this would be like this. New command. Okay. So then this is the structure that you would end up. Oh, I don't like those line breaks. So hopefully this kind of goes.
Hey John, is there something that kicks on in the background there every so often? It's like I'm getting a bunch of background staticky noise from you every so often.
My fan is running pretty hard right now.
Ah, I wonder if that's what it is.
It could be it.
Carry on. It's not a big deal. I can still usually make out what you're saying.
Okay. So that's kind of the API we're aiming at right there. Just to put the test back to where it was.
And I'll just jump in here too. So it's worth pointing out for people the API that we're looking at here. This is the core API that's in the System command line library. When you look at like a lot of other of the existing libraries out there, there's ones where you specify your options and arguments with attributes, or maybe you build up objects or various other types of things. We've tried to keep this library as agnostic of those individual preferences, as it were, just so that people can build those on top of this. So this core API aims to provide all of the functionality that would support, say, somebody building an attribute-based model or a class-based model. And we don't want to block any of those options or take a hard stance on any of them. And Dragonfruit's just one example where we feel that a nice, easy interaction model is strongly type your main method and be done. But there are some limitations that come with that where some other app model might be more useful, or somebody might feel a little bit more at home with it. So be aware that if you hear kind of that term thrown around of app model, that's usually what we're referring to as something built on top of this core API that puts a prettier face or interaction API for somebody to work with. Which I think that may have been what you were referring to a little bit earlier, Tide, as far as how to go through and interact with it, which is why there's kind of those two pieces of first kind of handling this multiple argument situation in the core API, and then exposing that further down wherever somebody needs to use it.
Yeah. So you can see a little bit of the core API here, right? In this test, for example, we're parsing some input, which the input is coming here from these data attributes in the XUnit series. So we parse the input, and this is just showing that different delimiters, right? An equals or a colon can be used to delimit the argument from the option, and that the parser understands that this is an argument even though it starts with a dash, which you might mistake that for an option, but this is just showing that the parser doesn't do that. So then I can get the value for option X, and that value should be Y in both of these cases. So I actually did write some tests for number 310. I think I have them. And so we can see what that looks like, right? So here's some of the multiple argument tests, but right now they're skipped, because I realized that there were limitations in the core parser that were going to prevent me from getting this thing to pass. We made some changes, so we said, for the command result, I should be able to get the several on the one. So here's the several argument, right? It has an arity of 3, 3, which means 3 tokens will be parsed into that argument, no more, no less, a minimum of 3, a maximum of 3. And there's this other argument, which is the one argument, which has 0 or more, right? So it's saying, these should be part of the several, 1, 2, and 3, and 4 should be part of the second argument, which is called 1. Does that make sense? Hopefully this test is not too unclear.
Right. No, the test makes sense. And you said this is part of what's still the work in progress, why you have it being skipped right now?
Yeah. Yep. The first kind of turn of the crank on this was to make the API able to handle this. So you could say get argument value or default. Now most people won't have to interact with this because the model binder will do it for you. You'll have some method that you say, hey, please call this method, kind of like a controller method in ASP.NET. The parser and model binder will, figure out how to satisfy the parameters of that method, and you shouldn't have to think about this too much. But if you do want to interact directly with the parse result, then you can pull values out of it in this way. And so what this is showing is a change that we made to show that, we have this argument here, to say which of the command arguments do you want, because there's potentially multiple of them. Right? So that's one of the changes there. So that, the API, what you can see here is that the API for both configuring the parser and for pulling values out of the parse result is working, right? The API shape has been changed to satisfy that requirement. but the core parser doesn't work yet for it. So that's kind of the next step. So I sort of put this set of tests on hold and went back to the core parser and said, what does this thing need to do differently for this to work? And that's when I opened Pandora's box.
Which makes sense. What was the rationale for why we didn't need multiple arguments on option? Was that just something we omitted for now because there was currently not a use case for it, or or am I about to open up another can of worms?
Well, no, we couldn't find a use case. There wasn't an example that we knew of. So Tom DeSane, who opened issue number 310, and he's a longstanding contributor as well in the .NET CLI. We hashed it out and kind of thought about how this would work. This arity thing here would need to work in this way because these are effective. You say in this case, right? I'm passing in 4 arguments. They could be of different types. Maybe I want some as string, some as int. So there needs to be a certain amount of structure, and the positionality is important. And we went and looked for examples of how this kind of thing is used in other command line apps. And in every single case that we were able to find, this only applied to commands and not to options.
Gotcha. Okay. That makes
so
sense.
That's the main reason.
Leave it until we need it.
Until we need it. There were a few other things as well that we said, there were a few other things that were on our minds as well as we started thinking about this refactor. Another one was, this is one, so we can go back to, we'll take a look for a moment at another limitation that we hit that is also kind of part of the motivation for this change to the core parser. And there's a first motivation that actually predates all of these, which is that the core parser was never as efficient as I wanted it to be. So we always knew we would want to go back and do some refactoring for performance. So .NET Try, it has this directory argument that's hanging out here. And it's a little bit weirdly positioned. So .NET Try lets me do things. So if I go to, go to the .NET Try docs, getting started, right? And so I can do this. I can say, actually, I'm just going to go somewhere other than that directory. Right? I can do this. I can .NET Try a directory. And this is this dir argument. It's saying, hey, what do you want to run this thing against? And I can say .NET Try, try docs, getting started. And it'll open up .NET Try in that directory. So you can see here, this is where I wanted .NET Try to run, right? There's another command here, which so what try.net is doing is it lets me write markdown files that contain documentation, and it makes the documentation interactive. So it stitches together text and code in a way where the code can be run right in the browser. One of the things that we said would be valuable here is that if you're writing documentation, you probably want to put it under test in your CI pipeline, so your documentation doesn't break. So we have this other command called .NET Try Verify. And some things are broken there. So this would let me say, I broke my docs, don't merge them, or whatever it might be. Now the unfortunate thing, and this is another limitation of the System.CommandLine Parser at this stage, is that if I do .NET Try help, I see this dir option here. It's this argument, right? Specify the root directory. But this gets awkward. And this bug is like fingernails on a chalkboard to me. But there's no straightforward way to fix it because we don't have the ability to say this dir argument applies at all levels of the command hierarchy. Right now, we need to redefine it at each level. Yeah, and semantically, they're actually two different arguments. So, yeah, this was one that we didn't get this fixed before our preview release, but it was another motivation for making the parser a little bit more sophisticated at the core. And the idea here, probably from an API perspective, is that we would be able to attach the same argument object at multiple places in that hierarchy that I was showing before. So with a collection initializer, you're able to create an option or an argument and actually add it to multiple different commands. And that would tell you this is valid in all of these different positions. That's an idea. So how do you go about a refactor like this? Oh.
Sorry, Tide. I've been trying to avoid feedback, so I've been muting and unmuting my mic. So I assume it's probably better now. I think I misclicked on my mute button. Cool. Yeah, so then where does that mean that you are at in this long... I guess that's my next question is where is the state of your branch and where is it needing to then progress? Because you also mentioned, because I know there's another outstanding GitHub issue for this, either cloning of objects like this argument or just being able to apply it at multiple levels.
Yep.
Which I think is similar but not quite related to this.
It's similar, and what I'm hoping is that we unblock a few different issues like that with this change. I can show you how we approached it, how the refactor is going so far, and sort of the approach that we're taking. And you can see here, I'm on the branch that has this in progress. So here's type conversion tests v2. One of the things that I wanted to be able to do was to refactor without ever breaking any of the existing functionality, right? So a refactor in the real purest sense of it is I'm restructuring code without changing behavior. Right. So here's a test. And if you look at the ncrunch glyphs here, you'll see that this test is both passing and failing. This is not a Schrodinger's cat thing. There are actually two versions of this test, but it's the same test. And so here, let's do
Hold on, two versions of the test. Is this like multiple target framework type deal, or?
No. So I pinned this so that you can see the passing version and the failing version. I'll unpin these for clarity. Okay, so the pinned tests here, these are the same exact test method. Right? One of them is declared, this is just the type conversion tests, okay, the class called type conversion tests. And then if I scroll way down to the bottom of this test class, I've added this little class here called v2, which inherits type conversion tests. But it flips this flag that I've added. Now this flag is just a shim. This is just a way to diverge between two different behaviors. So I can drive two different versions of the code with the exact same tests. Does that make sense?
Yeah, that's very clever. I hadn't considered doing that before.
So let's take a look at what this thing does now. Okay. So basically this says, I've got this test here, and I just called it v2 because it reads kind of, fairly intuitively in the test output. So I've got type conversion tests, v2. Okay, and every time I add a class like this, we'll see a whole bunch of tests now being run against both versions of the parser. And I know immediately if I broke the old version during refactoring, and I can burn down the failing tests on the new version. So just as an example of how I'm doing that, I'm just going to copy this guy And let's go looking for another test class. And I started out with, if we look at the ones that I've done so far, it's just these, right? I started with directive tests. That was a pretty straightforward one. Parser tests was a bit more complicated. Parsing validation tests, not too bad. Type conversions and model binding, we're starting to get into gnarlier territory. Let's just for entertainment purposes, let's go to the model binder tests. The model binder here, very much like the model binder in ASP.NET, System command line lets you bind complex objects. So I can do things like, I can create a class and bind options and arguments to the properties of that class. Model binding command handler test is actually good. Right, so I can create an instance of this class and see that the instance of the class is being bound. Right, so console out. Let's see, this is good. Yeah, these are basically what I'm doing with each of these tests. These are kind of hard to read, actually. They're a little bit inception-y. The model binder tests might be clearer. Right, in this test, I'm creating a class called a command. I have a class with a setter. I'm testing that the value of that setter, the value of that property is being set correctly. Right, so it's not just primitive. It's not just ints and strings and things like that. It can be complex objects. We'll pass parameters into the constructors, into the setters, things like that. So anyway, let's jump to the fun part here. I want to paste in this class. I don't know if I need this constructor, but we're going to inherit model binder tests. It compiles. Let's see what happens. Wow, I was not expecting that. Okay, so what just happened? I'm going to go in here and I'm going to pin this. I'm going to pin model binder tests. I'm going to pin model binder tests v2. All right, so now you can see model binder tests and model binder tests v2. I have two copies of the tests. One's being run against the old parser, one's being run against the new parser, and they both all pass.
Whoa, that's kind of cool. That's remarkably impressive.
Yeah, I'm hoping that the implication there is that the parser tests hit most of the hard parts, but I'm not sure that we're done yet. In fact, I'm very surprised that worked, that those tests passed. But the model binder is at a higher level as well. So if the core parser is working correctly, then all the stuff that builds on top of it, like model binding, should work. We can try another one if you want, or we can start looking at the design of the parser itself, or whatever. What's interesting?
Well, I was going to say the design of the parser itself, I guess, is what's interesting to me, unless anyone else wants to throw out some options. I don't know how long you wanted to run tonight, John. I know you had initially said maybe about an hour-ish, and I know we're coming up to that, so I don't know how much time you have to dive into the parser design or not.
Oh, I can take a little bit more time. This is the last code-related thing I was planning on doing today, and I've already eaten dinner, so it's up to you. I'm happy to go on.
Yeah, I mean, I'd love to take a look at that parser design and where it's at.
Okay.
And get a better understanding of it.
Sure. So yeah, this is an interesting sort of design and refactoring problem. I'm going to look first at the old parser. Actually, let's start with use new parser. So this is just a static method that I added to the command line configuration class. And if we go and shift F12 on this, we can find a bunch of uses of it. Here's the main one. This is the shim that when the test says use new parser true or false, right? This is where it diverges. So this is the meat of the old parser, and this is where we diverge and go into the new parser. There's other places as well. So there's another important one. So yeah, this is where you get the arguments effectively that get passed into main in your normal entry point. And we create a command line parser. We parse the arguments. Raw input is worth talking about maybe another time. And we get back this parse result object, which is, we've been calling this an AST, an abstract syntax tree, right? It's kind of like one, but it's not really. In the purest sense, it's not. But what this thing represents is it has, here, let's look at the structure of this. Right? It has a bunch of information about the parser, the parse result, right? It has the directives, it's got tokens. These tokens are just, what are the strings that we actually figured out are inside of there. Parsers typically have a tokenization step, which categorizes the strings semantically, so that the parser is dealing with semantics and not the strings. That stuff, the old parser did that, more or less correctly. We have this unmatched tokens, unparsed tokens. So this tells you a bunch of stuff about what the parser thought about what was going on in there. And the real goal is we create this root command result, and there's also a command result. So we have a subcommand. These things are telling you, here's what we found out about this command, and then that has options hanging off of it, or option result objects hanging off of it, and the option results and command results have argument results hanging off. So those things allow you to go and interrogate for strongly typed values and find out whether an option was applied or not, find out whether an option was implicit or not because it had a default value, all kinds of things like that. So those result objects, the command result, option result, and argument result, they all inherit symbol result. So you can see what this thing looks like. So this is kind of taking two different concepts and sticking them together in a way that made things a little less flexible than was ideal. And those concepts are, one is kind of the abstract syntax tree concept, right? And the other one is kind of related to model binding. So it's like an abstract syntax tree that knows how to convert things into strong types, like, the types that you configured the parser to ask for. Give me ints, give me dates, give me file info, whatever it might be. So I started scratching my head, and I sit next to the Roslyn team, and there's lots of people who know more about parsers than I ever will nearby. And I started scratching my head about this idea of writing a more correct parser. And what does that look like? So let's look at the object model for the more correct parser, and you can ask me questions about it. So in here, I added this parsing namespace, and it's got a whole bunch of types in it.
Yeah. Oh, okay. There is a lot of new stuff in there.
Yeah. And it looks like a lot of new stuff, but it's actually extraordinarily simple. Here's an example. Right. They're just data structures, really. So whereas the old command result class knows all kinds of things about both about the raw tokens and it knows things about the parsed input, but it also knows things about the expected output of that parsed input, like how we're going to convert it into other things. So that those classes are quite complex, whereas this is a little bit simpler. So we have tokens. Tokens have been there since the beginning, roughly. Right? A token is, I took a string and I categorized it. That's what a parser does. Before doing the core parsing, most parsers do tokenization, which they categorize things. So you'll see this is token type, and these are the different token types that exist in System.CommandLine. A lot of parsers will get even more detailed about tokenization, and we might get there eventually. You might have tokens for things like the opening square bracket and closing square bracket on your directive. Or you might have a token for a colon that separates an option from an argument. Right? Our tokenizer is not that detailed. It hasn't needed to be. And in order to keep the API surface similar enough to be able to switch on the use new parser flag and go down one path or the other and have the exact same test, it was useful not to try to add functionality yet at that level. Does that make sense?
Yeah, Yagni. I will say this feels very Roslyn-esque for anyone who's maybe built like their own analyzer,
Mm-hmm.
very similar to that same type of structure.
Yeah, definitely. I mean, I spent a bunch of time looking at the Roslyn source code and thinking about, more, the way parsers are built by people who know how to build parsers. Right. There's certain kind of rules and structures to them that are really pretty common, and I never took a parser class, or else I would have probably known that, but I had a sense of it, and so it was a good learning experience to kind of dig into this and say, okay, how do you actually build a parser?
Real quick, there is a question out there of, you want to go back and give a brief overview of what a directive is?
Yeah. So let me give an example. A directive token is this right here. Parse is, if we're talking about just the language or the what are the syntax concepts that exist on the command line in System command line? We added this idea of a directive, which you don't see this in other. This is, as far as I know, this is a fairly novel concept, and it solves a few different problems. So, say I want to do .NET try demo output C. In this case, what the directive is doing is it's saying, I'm actually going to change the meaning of everything that comes after it on the command line, and I'm going to give you back a representation effectively of the abstract syntax tree of the parse result. Right, so it's a way of using the parser, rather than using it to go and call my command and actually invoke my app. I'm saying, tell me how you interpret this input. Right, so you can see here this sort of nested structure where .NET try is a command, demo is a command. Here's the output option. Here's the value that was passed to the output options argument. This little asterisk here means implicit. So add package source was implicitly supplied because we defined a default for it when we configured the parser. So that's what this is doing. If I had said something like, it's a good one, like, let's try that. Oh, that's a comment. Yeah, there we go. Oh, that's interesting. I'm trying to give it some invalid input. Output seems pretty flexible. What's a character that is both not?
So I think something you said earlier that I think made it sound fairly clear is a directive in its general sense is sort of a cross-cutting command or behavior for command line. So it's not necessarily specifically tied to any one type of command line, but they usually represent common functionality that you might want across all of them. So as far as the question of is it just for debugging, the parse directive is largely just for debugging, but there's other directives that exist out there for various purposes. I know that there is some directives in there around the rendering stuff, and as far as like enabling or disabling VT100, that kind of thing. So again, they're more cross-cutting options that you might apply to any command line app rather than just one specific one.
Yep. Yeah, that's a good way to put it. I've also made the analogy that they're kind of like HTTP headers.
Oh yeah, I like that one too.
So here, what I'm showing is just the suggestion feature. And the way that this works is also with a directive. So what's happening here is as I tab through, it's saying, these are all valid input at this level. The core parser itself understands this and is able to output suggestions. So how do you ask it for suggestions, right? This is the .NET Try application. It doesn't have any special logic in it to do suggestions. There's no custom script that's specific to .NET Try to do suggestions, that's kind of the traditional way to provide suggestions on the command line. Is you write a shell script, right? It'll be bash specific or PowerShell specific or whatever. So the way that this works in System command line is we have a suggest directive. right? So suggest says, hey, take the input, parse it, tell me what are the valid suggestions at this point, right? And then that's the way that we have another application called .NET Suggest, which we have a script that passes the input through .NET Suggest to your application using the suggest directive to get back the suggestions, right? So it's a cross-cutting piece of functionality. You sort of opt into this functionality by using System.CommandLine, and as long as you have an application that sort of follows this protocol, which we provide for you in the box, then the suggestions feature works. So that works with a directive as well. You could imagine, the mechanism is extensible, so you could add directives for anything that you might want to. You could add your own directives via the middleware mechanism. You could add directives for logging or whatever you could think of, really. We've used it for a bunch of things.
Sorry to derail you there for a little bit.
No, it's cool. Questions are good. So to get back to the new parser, what this thing is doing, pretty similar to the old one. It takes in some arguments, raw input, right? It has to conform to the same API. It in fact inherits the old parser. That made it easier to shim it into a bunch of places, like the command line configuration as a reference to the parser and so on. So we tokenize things. The tokenizer has been rewritten. I had taken the same approach, but the old one is gone now. So the tokenizer takes in strings, and it returns a bunch of a tokenized result. So here's those tokens again, the different categories of tokens, as well as errors. So then we take the tokenized result. Sometimes this is also known as lexing. In parser terminology, lexer and a tokenizer are the same thing. So now we have a parse operation. This is a new internal class that is driving the new parser. What is that? We tell it to parse. And then we've got this parse result visitor. And the parse result visitor, we tell it to visit this root command node thing, which is one of these syntax node types. And then we return the visitor result. So this is kind of the high level structure of a new parser. So let's look at the parse operation. You can see that this is tracking state. So this is basically iterating over the tokens and figuring out what they mean with relation to the command line configuration. What are the options you specified? What are the arguments? When you configured the thing, you said, yeah, I've got a command called the command, and it's got these options, and these options have these arguments, and they should be these types. And so this style of parser is something that is it's a recursive descent parser. That's the rough description of the kind of parser it is. A C# parser is also a recursive descent parser. Obviously, this one is vastly, vastly simpler. And what this is doing, here's the basic operation. There was a parse method, right? It starts with a root command node. What a recursive descent parser does is it recurses into some structure, and it calls a bunch of what are supposed to be mutually exclusive subroutines that break things down into different semantic groups. So what you can see here, right, the parse root command, we know we're starting with a root command. The tokenizer normalizes that for us, so the root command will always be your application name itself. So we say, hey, get me the root command node. And this advanced thing, it's just iterating. We're just keeping an index into our position inside of the token list. And we advance when we feel like we've successfully categorized the current token. We move on to the next token. And so for each one, we say, okay, well, what are the things that we want to parse at this stage? Directives always, this is one of the rules, directives always have to come at the beginning. So you can really see the high-level parse operation in parse root command. We start with the directives, then we parse command children, right? And subcommands can be nested as deeply as you want to go. So this is where things get recursive. And then there's this parse remaining tokens. But most of the work is actually happening inside of parse command children. We say as long as there's more tokens, right? And if it's not the end of the arguments, that's that double dash thing, then we say the child is either going to be a subcommand, or it's going to be an option, or it's going to be arguments. If we don't match any of them, it's an unmatched token, we move on to the next one. Otherwise, we add the child node. Right, this is itself recursive, so we pass the command node into parse subcommand. So what does parse subcommand do? Well, same thing. It looks for a command that might be appropriate at that level. So I've got a command, and it goes again into parse command children. So you can see that this structure can recurse endlessly. Does it make sense? Do you want to step through it?
I think it makes sense, but I wouldn't mind like grabbing one of those unit tests and walking through this just to see it.
Yeah, let's do it. Let's take a look at, let's do one that passes, because that will be probably less confusing. Parser test. How's this one?
Seems simple enough. We've got a root command of 1. 1 has a subcommand of 2 and 3. 2 has a subcommand of 3 as well.
Yep.
Okay.
So there's a little bit of ambiguity there, potentially, right?
Right, because once you do the 1, 2, 3, that 3 we expect to be the subcommand of 2, not the sibling of subcommand 2.
Yeah, yep. Okay, so let's start with, let's put a break on here. We're going to debug version 2. Okay. So what do we have here? We have an index of 0. Right? That's our position inside of the arguments that were passed in, or the tokens that were passed in. Let's take a look at the tokenized result. Remember, we're coming from the tokenizer here. So the tokenizer has already done some pre-categorization of this thing. So here's our tokenized result. Right. So far, so it didn't produce any errors. It has 3 tokens: command 1, command 2, command 3. But the tokenizer doesn't understand the hierarchy of them. They're just tokens. It's just a flat list. So we're going to start we always start with parsing the root command node. All right, so current token, that's command 1. Current token is a really simple little method. It just offsets into the tokens list by the index. So advance, when we call advance, it'll increment the token. So current token will always contain, just return the current one. The configuration root command, this is our description of the parser configuration. So this has got a lot of information in here. So this is what we're parsing against. Okay, so here's our root command. Passing a token to root command, there's 1. Non-terminal syntax node means it can have children. Okay. We keep a reference to the I command object, right? So this is the thing that we configured in the test on the right. This command instance is the thing that the token now refers to. All right, so here's this syntax node. We know what the token is that was passed in. We know which command object it references. So far, we don't have any children for it. So we advance, just increment the index. Now we're going to parse directives. So more says, is the index less than the number of tokens? Yep, there's more. Current token is 2. The token type is not a directive, so we're done with parsing directives. One of the rules of directives is that they have to come first. They come directly under the root command, but once you've encountered a token that isn't a directive, nothing else will be counted as a directive. If we did 1 square brackets parse 2 square brackets something else, that second square brackets instance would be it wouldn't be counted as a directive token. It would be counted as an argument or something. So we're parsing command children now. Right? So there is more. It's not the end of the arguments yet. So parent is 1. We're going to go into parse subcommand. It is a command token type. Right? We find that there is a command that has that name, too. Right? It matched something that is in the configured list of commands. So we'll create a command node for it, which is another, just like we saw before, it's a type of syntax node, just like the root command. Okay, so we've got a command node. We're going to advance. And now we're going to say, well, does it have children? Right? And this will, if we had a hierarchy that was 100 subcommands deep, this would just keep recursing farther and farther into that structure. Right? If you think about the way C# is parsed, it can have expressions inside of expressions inside of expressions inside of expressions. So the recursive descent parser gives you a way to kind of keep just digging and digging and digging. As long as that syntax, as long as that grammatical concept in your grammar is itself recursive, then the parser follows, the code structure of the parser follows the structure of the grammar. So it's easier to reason about than our old parser was, certainly.
I completely agree with that. This is by far simpler to step through and understand what's going on.
Yep. It also uses a lot less link, so the number of allocations should be vastly lower. So from a performance standpoint, this parser, I haven't measured it yet, but I'm pretty confident this parser will be a lot faster than the old version as well. Okay, so in this case, right, we've got a child. Child node is 3, right? So we've recursed all the way into that inner command, right? And now we're going to come back out. Right? More was false. We return this command node, so here's 2. Coming back out. We add that one to the tree. Keep coming out. There is no more. Again, okay. So we're done parsing command children. Everything was a command child in this case. Right, so here's our root command node, and you can see now that it has a child which is 2, which has a child which is 3. Right? This is a more true abstract syntax tree than what we had before. Parse remaining tokens. So if you wanted to step through it again with an example that uses the end of arguments thing, you could see what that means. But remaining tokens basically means, was there other stuff that didn't fit underneath any of the commands? So the double dash is a POSIX convention that says everything after this, just gather it up and give it back to me, but don't worry about what its structure is. It's just a bag of extra stuff. The other thing that can be in the remaining tokens might be unparsed tokens. If we find tokens where we're like, I don't know what this is, it doesn't match anything, then those can be returned as unparsed tokens or unmatched tokens. So there you have it.
Cool.
So now we've got hanging off of the operation. We're not done yet, though. So here's that root command node, right? We grab that. We don't have unmatched tokens or unparsed tokens. We don't have any errors, so that's all good. But now, to conform with the pre-existing API, we now need to take the syntax tree and turn it into those command result, option result, and argument result objects we had before. How do we do that? So this is kind of the step now where we really, like the new parser is really more decoupled from those other, from the object model that we want to get to. So we have a parse result visitor. And what the visitor does, let's skip the constructor and just go right to visit. We pass in the root command node, and what this does is it recurses down the syntax tree and builds up some other thing. And you could have a visitor that does any number of things with this. So maybe we'll end up with a visitor for help, or maybe we'll end up with a visitor for suggestions, or maybe those things all work today. So there's not necessarily a structure, a driving need to rewrite them. But you can think of the visitor as a reasonably efficient and again pretty easy to reason about way to take the syntax tree and do something with it. And in this case, the something we're doing is building that parse results object. Right, so here's our root command node. I'm building a root command result. So this is that old command result object that we were looking at before that was kind of conflating the structure with the model binding stuff. Right? And then we just iterate over its children. And so what you can see if you look at the structure of this thing on the left here, right? It just has methods for visiting all of the different syntax node types. And so all it's really doing is just building up the parse result, which our API, both the old version and the new version of the API, they're using this, or that part of the API is not changed. Right? We changed the parser underneath it, but that API surface of the parse result class and its children has not been changed, which is why all the tests can work against both versions. So yeah, just to come back out to the test. All right. Here's our parse result.
Cool. And the string representation is just that diagram, which is the same as what the parse directive ends up giving us.
Exactly. Yeah.
Seems so simple. But simple code is always the hardest to write.
Yeah, it's simple, but it wasn't simple when it started. The first iteration was not simple, but this one's a lot easier.
Well, I think the saying is, until you've rewritten your library the third time, it's not actually good. So, is this number 2 or 3?
I think this might be number 3.
So
number 1 is the one that's in the .NET CLI. Number 2 is the one that's been called System.CommandLine since around the time that you joined the project.
So at this point, it should be getting rather stable then.
I think so, yeah. I mean, the simplicity of the parser is something to get back to the original reason for this refactor. Right? Making that parser simpler and easier to reason about should also make it easier to change its behavior and extend it. And so being able to add multiple arguments now should be a lot more straightforward.
That makes a lot of sense then. Because in theory, it's just a matter of going through and saying, rather than looking for a single argument, add an extra one inside of that method that was handling the, was it command node? Command syntax node?
Yep.
Seems like just based on what you showed, that you're fairly close. Maybe that's a bad assessment, since there was a bunch of failing unit tests, but is the intent then, before this merges, to ultimately whack all of the V2 unit tests and just have that static property go away and the true version of it be the only thing that remains?
Yep. Yeah, that use parser method, or use new parser method, we can look at the places where this is in use. What this is really doing is it's just like while we replace the plumbing, this is the diversion pipe that things can run through, right? It's a diverter, and we have 2 different code paths we can take, but we only need 2 code paths to make sure that we don't break the old functionality while we're building the new functionality.
Right. I'm actually in the middle of a large refactor on one of my projects at work, and I'm kind of wishing I had adopted a structure like this. Because right now the solution is the project's cloned twice. Once pre-refactor, once post-refactor, and so you do have that issue of when you're halfway through, there's a bit of confusion of, is this something new that I broke? Is something that used to work differently? And
yeah,
I'm going to be stealing this trick on future projects. This is a good one.
Yeah, it's a pretty good one. It took me a bunch of head scratching to figure out how to approach the testing so that the refactor could be done in a very gradual way where I was always moving forward. It's really unfortunate when you get into the middle of a big refactor and you're like, oh, I've hit a dead end and I now need to figure out how to unwind all of this. Right. So the test design is really critical for being able to say, lay out a strategy for making deterministic forward progress.
Yeah, and I think this really helps with that issue of needing to step back, because with this, it doesn't feel like you really need to step back that much.
No.
Cool. Well, sweet. I guess then one last little bit, not to divert too much from this, but so this refactor is currently being done out on a branch on your fork. What about stuff if people want to actually get involved and commit back? Where would you suggest somebody dive in and get started or take a look at? I mean, obviously, the easiest thing to do for anybody wanting to help out is just pull it down and use it and provide feedback. I mean, that's invaluable right there. But if somebody actually wanted to do some work and submit a pull request, where would you suggest starting from?
Well, so if we look in the GitHub repo, we've got plenty of issues open. And some of them have tags on them, like good first issue. So I feel like, is there a PR open for that? Oh, there is. Gotta go back and ping that person. I had a very busy week and dropped that one on the floor. So good first issue, if we look at the labels here, is these are things that we've tagged these issues specifically because we think they're scoped enough that someone who's not super familiar with the code base has a reasonable chance of succeeding. And also the general rule in the .NET team for when we apply the good first issue label, it also means we have volunteered to help someone move a PR to completion. So anything with a good first issue on it, there is someone on the team signed up to help you if you want to grab it. So that's a good start. Help Wanted is here too. Help Wanted and good first issue typically go together, although Help Wanted sometimes might be a little bit more complex. Do we have one that's Help Wanted but not good first issue? I don't think we do. So that's a good way to start. And then there's tons of other issues, which they're all up for grabs if they don't have someone's face on them, which is mostly the case. We try not to have too many things in flight at the same time. So there's lots of stuff in here, and they're categorized. Some of them are bugs, some of them are enhancements.
One other thing I'll point out too, I think there's a link on the README, but there is also a Gitter chat room too if somebody just wants to pop in with a quick question or comment. I believe it's linked right at the top. Yep. Yeah. So if anybody wants to jump in, or you've got feedback or a question or running into a problem, that's a good quick place if there's not a corresponding issue to type a comment or question on as well.
Yep. Yeah. Yeah, and we're always keeping an eye on that, answering questions about how to use it and things like that. And Twitter works too.
Awesome. Well, cool. Was there anything else you wanted to look at, or did anyone have any questions or thoughts? I may end up I normally go 2-ish hours, but I may wrap this one up early. I had an early morning, so if I don't quite hit the 2-hour mark this time, I'll be okay. Thanks for jumping on with this, John. I've missed our coding session, so this is
me too.
This is good to get this going.
My my not so secret agenda was to nerd snipe you in order to get some help from you. So.
Well, and I'm always happy to dive in and help as well. Well, while we're on the topic of nerd sniping, I'm going to just throw in something that I did because I think it'll be fun. So I ran into a issue the other day on one of the projects where, and this is absolutely nothing related to System.CommandLine, but the need to go from a type object for a given delegate type and actually create an empty version of said delegate. So,
oh dear.
Yeah, I'll throw a link to this, John, and so naturally I had to go through and do it, and it took several tries. I can pull it over onto my screen here. If anyone's interested, this is the repo in question. But there's so I put together just a small unit test project, but the interesting part in there is a solution branch if you want to see a fun way of going through and solving it. I think I've covered most cases, and at least for the project in question, it covered all the cases that mattered. I'm not 100% confident I haven't missed something somewhere, but it does open up the solution ended up being less than 40 lines of code, including white space, which made me just happy. And there's certainly room for improvements as far as like caching the generated delegate, because obviously if it's an empty delegate, you can cache it by type and get away with that just fine.
Yep.
But, so on the topic of nerd sniping, if you wanted a fun coding challenge, there's that was one that it came up, and we sort of cheated it on the project with mock initially and kind of worked around it that way. But I was like, no, there's got to be a way to do this. And so I had to attack it. Expression trees was my first approach, but I ran into issues as soon as I got to out and ref parameters. Just with the limitations of expression trees.
Yep.
And so then I decided, well, let's just keep going deeper. So made for a fun little project. So
looks like a good time.
Yeah. One way to burn the midnight oil is getting nerd sniped by problems at work and then having to go home and solve them.
Yep.
So.
Yeah, a very like small scoped but tricky problem like this can be very entertaining.
Yeah. So I figure I spend a little over an hour on it, just kind of hacking away, trying to figure out what would work and what wouldn't.
Mm-hmm.
And then my personal favorite that I did not realize is that void is technically a value type, which I had never initially tripped up my code, and it took me a minute to realize what was going on. But then the other fun one is the I don't know if you can see my screen, John. Probably not.
Yep, that's it.
So the return type for value types,
mm-hmm.
it just pops a 0 onto the stack for
mm-hmm.
any value type, regardless of what it is. Because the whole type conversion stuff is more a C# thing than an IL thing, so we'll just treat the type system as a suggestion, not a hard and fast rule.
Yeah.
So it works. And then, yeah, some ugly stuff around generating up tasks because I didn't want async delegates to throw
mm-hmm.
nulls on awaits.
Mm-hmm.
And again, something that probably should have been built in cache somewhere, but good enough for this.
Very nice.
So, well, cool. Well, thank you everybody for jumping on. John, I will so the video for this will be up on Twitch, but I usually export them to YouTube as well, so that'll probably show up here in the next day.
Great.
Whenever I get around to clicking the button and applying the tags. So.
Nice.
Well, cool. Well, you have a good night. And if you want, I'm happy to jump on if you want to do some pairing sessions on working through some of these refactors, or maybe I might just pick up some of the issues on the repo. I know there's also some rendering stuff, and I've found some bugs while trying to use my own rendering code that, like, wow, I did not unit test that as well as I should have. So I know there are some issues in there that I may end up having to just dive in and fix at some point. So.
Yeah, I would. There's a good amount of interest in that stuff. So getting that getting that working and getting the API into a more usable and stable state would be great. I think this, especially with the Windows terminal, the new Windows terminal, I think that the VT100 stuff is going to have a resurgence. So but either way, yeah, I would love help on this particular piece as well, and reshaping the API, getting number 310 fixed.
Sorry, looking at this comment here. Task case with generic, it should use the other code paths for value and reference types. Let's see.
Uh-oh.
136. So it won't. So it shouldn't fall into the value type one, because the checking on the return type of task itself. This is the class task, not the value task generation. To create the default value to be on the stack before calling task from result. Oh, I see what you're saying. So from result needs to actually emit out the parameter for there. I believe you are correct. Which means my unit test is not good enough for this. Yeah, no, I think you are correct, and that is a bug in this. Because it really should fall through and generate the appropriate one.
Oh.
Yeah, because I'm guessing my unit test must be... Let's see, where is this guy? It's probably, yeah. So it's working because my unit test is testing on task event.
Oh.
Which you make this a task of something else, and now we've got a problem.
Got it. Yep.
So, thank you. I appreciate that. I will go and get that fixed. Good catch on that one.
Nice, yeah.
Sweet. Well, I will wrap this up. John, you have a lovely night. We'll do this hopefully again in not too long.
Yeah, this is cool. Thanks.
And thank you everybody for dropping in on the stream. Like I said, I'll have the video up, posted probably within the next 24 hours. So, talk to you later.
Great. Good night. Talk soon.